Hi, this is a video, possibly one in the series of videos, that will go through how to build a seismic analysis in FLAC for an embankment dam, for geotechnical analysis. So we're going to start with a folder here on my laptop, and there's only 3 things in this folder. There's a shortcut to the FLAC executable, and so we'll have to open up FLAC first, but notice that the start in box is cleared out, so that means it'll start in this window here instead of having to navigate from the C drive to your project folder file here. Also notice you might need this space GIIC 500 for it to start up. You might not. This isn't the target. I had to write this in. Okay, so let's just open it up. This is FLAC 8.1, and since this is in demo mode, I have to hit continue, and it'll open up. And we're going to pick a project, and we're going to pick the project that I have already set up. We can look at the model options first. When I first set it up, I had a groundwater flow checked, dynamic checked, adjust total stress checked, and 95 extra grid variables. Also, you'll notice we're in the imperial units here. So we have no anything happening yet. This is just a new project. So I'm going to put it on the side over here. Now the other thing we're going to do, we're going to build this file using FLAC commands. We're going to build this analysis using FLAC commands. So FLAC commands are just in this notepad++ file, and we're going to move that here. So this, you can see that the comments are green and some of the commands are blue, and that's because I have fish as the language, set as the language for notepad++ to know what it's looking at. You can download the XML from Itasca's consulting group's website to get that, and it makes everything a little bit easier to read. Okay. So let's go ahead and see what we're doing. We're going to make a seismic analysis. We're going to use the Moore-Coulomb solar model, and we're going to have excess pore pressure generation during the model. So that means it's a coupled analysis, undrained coupled analysis. You know, getting close to reality, except the Moore-Coulomb model is good, but there's better models out there. But this is a good starting point. So we're just going to go through these commands, and then we're going to run the model in pieces and see what shows up in the graphical interface over here. So you can type these commands into your own text file and follow along that way. It's a lot of typing, but that's one way to do it, and at least you can pause the video. So the first few lines here, you always start with new. That just says FLAC. This is a new file. And this is important here. We're configuring some of the settings right away. So we're going to configure that it's a dynamic analysis. And that's short for dynamic. And this is GW, which is short for GW flow, which allows for excess pore pressure to be generated during the analysis. And it also allows for a seepage analysis. And this is for extra grid variable and 95 of them. And then we're configuring for the adjust total stress. We're also going to set our gravity constant at 32.2. And then we're going to set flow off right away, and dynamics off, and echoes on. So when you set flow off, that means that you are running an analysis where it's an undrained analysis, but the flow does not go from element to element. Okay, dynamic off because we're going to do some static calculations before we get into the dynamic portion of the simulation. And echo on means everything that is read into the console here is echoed into this console area up here. So then we're going to set for small strains, and we will turn it on to large strains later. And this is what I was trying to say before. So the water bulk command says to FLAC that the water bulk modulus is 0 psf. So that means that any loading, the water will not take on that loading. So it's this makes it a drained analysis when you have this set to 0. when this is set to a real number, like a real value of bulk modulus of water, sorry, then it's an undrained analysis and there's a response in the pore pressure. But if it's 0 PSF like it is here, there's no response. So we'll change this number later. And the water density. Okay. Step 2 is to create the mesh. So in another video that I made, I walked you through how to use the Geek over here, the graphical interface, to come up with these commands. So if you follow that video, you can get these commands. And then also we're going to make the model elastic for all of the elements. So we're going to run this. Here we go. We're going to run this text file. And it's going to go to this line 34 here, because that's where the pause command is. So remember that the project file that we're in over here is in this folder, and so is this text file. So when that happens, that means when that is true, we can come into the console file here and say call, and then paste in that file name, this file name here, with the .txt, and this should run up to the pause, which it did. So you can see mesh generation, mesh grid generation here, and the last command was model elastic here, which is shown here. So let's see what that did for us. If we hit refresh, so all this has done so far is it's set the initial configurations, and it's made a grid with a mesh and some elements. So it doesn't look like an embankment dam, that's coming later. But we can also do a plot of the soil model. So you go plot, model, and then we're going to name it soil model. And we're going to choose grid, because we want the grid in this plot. And also we're going to choose model. So this model means soil model. It's a little confusing because model is also what this tab is called. But this tab is FLAC's default plot, and it just has, it always has the elements. But we created a new plot we call the soil model. So you can see the entire rectangle is elastic. So if this was more Coulomb, then this would say more Coulomb up here. But so far it's just elastic. Okay, so now we can unpause this. And now we can go to the, we'll keep it paused for now. We're going to hit continue and see what happens. So this model will go to, actually I'm going to comment it out, yes. So now the next few lines of code or commands are going to insert some tables into FLAC. So if I do continue, it's going to read in from this pause that is now uncommented out into the next pause. Okay. Now we'll hit refresh, and nothing looks like it happened. But if I go right click, show the tables, and show all the tables, now we can see that some tables have shown up. Okay, so table 1 was the upstream shell, and you can see it starts here. So now it's starting to look like a dam. So the tables are just lines in FLAC shaping the mesh. Okay. The next lines of code that you can type in. So what we're going to do is we're going to make a ground surface table. We're going to call it table 141, and it has these X and Y coordinates. Okay. And also at the same time, we're going to generate the table, and we're going to null out the regions, model, null, region, with this element in it. And this element is this one up here, 114. And this element, 3714, is this top right element. So these commands were gone over in the other video where I showed how to build the mesh. So if I hit continue, if I type continue in over here, it's going to now create the ground surface and get rid of these two ends, the top parts of the model. Okay, so I'm going to hit CONT, which is short for continue. Now I'm going to refresh the model, and now it looks like more like a dam. Okay, the next step is we're going to make the downstream bench look a little better. And this is done by using the initial X, Y command for this grid point. So if you look here, if we'll zoom in on this downstream bench, you can see these two grid points aren't exactly where they should be according to the ground surface line that we had created. So the way I got these commands was I went into alter shape and clicked point, and then I moved these around. And you can see that's almost, that one movement is close to here, is almost this command here. INI X24 and Y990. Okay, well actually it's just 21.5, so this is this button, this grid point, sorry. 2410, 2410. Okay, so that's how I did that, and then I went ahead and executed it. This is before, and I grabbed those two lines of code, and then I changed them to have exactly 24.0, the exact XY coordinates I wanted, and then I put those commands in here. But we're not going to do that here, so we're going to go clear. Okay. So now we are at the point where I'm going to hit continue, and we're going to go from this pause to this pause, and we will see that these will move into the spaces that we want. So if I hit, so now you can see that it looks much better. So that you don't need to do that, but that's what's happening here, right? Okay, the next thing we're going to do, no, I forgot, we're going to show you this. So here's the geometry we've built, and here are the names of the soil in the model: upstream shell, core, downstream shell, foundations, and bedrock. All right. Now the next part, we're going to, here are the inputs for the More Coulomb soil model by soil. And we're going to input all of these into the model in the next section. Okay, so this is, now you have this table here. You can look at it if you need that. Okay, so the way we do it is very simplified. I use this, we're doing it by group. Okay, so a group in FLAC is a soil region. So we're going to plot that up first. So we're going to go plot model, and we're going to go grid in the background, group, we're going to call it group, and then we're going to hit OK. So right now there are no groups, user-defined groups, there are none, and that's why it's blank, but we do have the grid in the background. So we're going to fill this in with this code over here. We're going to make a group and give it some properties. All right. So the way you do that, so for the upstream shell, we use these 4 lines of code. We use this group, and then we name it with a string variable, the upstream shell, and we're assigning it to a region that has table 1, that is enclosed by table 1. Now remember, we can see table 1 on this plot. This is the model plot, not the soil model. See, it says 1 here. So that's that line goes from here over to here, up here, and then down here. So it's the upstream shell. And table 1 was created above on line 37. Okay, notice that it was enclosed, the XY coordinates enclosed itself, which made a enclosed shape. And when it's an enclosed shape, then you can use this series of commands here: group, upstream shell, region, table 1. So it's making a group out of this region that is defined by table 1. All right. And then now that FLAC knows, after this line 75, FLAC knows that that group, anything, so you can now, it now knows that that group has a name called upstream shell. So what we can do is we're going to say, okay, we're going to give it a model more, so that gives it the soil model More Coulomb to this group. And then we're going to give a property, so we're going to give it different soil properties for this group. So what's happening here is this D stands for density. It's 3.42 slugs per feet cubed. Here's the shear modulus, PSF here. Here's the bulk modulus. Here's the cohesion, friction, tension, and then the porosity and permeability. So all those numbers that were on the tables before are being input here for the upstream shell. And then we do it again for the downstream shell. So the same code, different numbers for the downstream shell. So what I'm going to do continue, and it's going to go from this pause to this pause, and this should fill in with all the groups. So continue, going to refresh. Okay, so now you can see that the groups, upstream shell, it's hard to see probably, downstream shell, core, foundations, and bedrock are all here in the legend. And so now we can see that we have built the groups. Now we can also look at the soil model, and now it was no longer elastic, it's now more Coulomb everywhere. Okay. Also, we can now look at some of the properties. So if you go plot, and then we're going to call it friction. Okay, so we come down to, let's see, properties, plastic, Coulomb, friction. So now this shows the 32 degrees up here, 28 in the middle, and 36 in the bedrock. Okay, so that's where we're going to stop for now. The next section, we'll continue on to the first solve elastic down here.